Hello, today I'm going to be talking about dynamics. Specifically, I'm going to look at Newton's second law of motion and apply it to a problem from an AP Physics multiple choice section exam. So, we know from Newton's law of second motion which explains exactly how an object's velocity is changed by a net force. So Newton's second law states that a net force applied to an object changes an object's velocity, which also known as produces an acceleration, and is frequently written as the following formula. Sum of F is equal to the net force, which is equal to the mass, also known as the property of inertia, times the acceleration, which is also equal to mass times the derivative of velocity. So essentially acceleration is equal to the derivative of velocity, which is explained more in kinematics. So it's important to remember when looking at Newton's second law of motion that both force and acceleration are vectors, and therefore the direction of the acceleration or the change in center of mass velocity of an object will be the same direction as the net force. So you can also look at you can also rearrange the equation to look something like acceleration is equal to net force divided by the mass or property of inertia. So you can analyze many situations using Newton's second law of motion. Some basic steps are first drawing a free body diagram, second to break forces up into components that lie on the x or y axis for any forces that don't line up with the x or y axis. Third, you can write expressions for the net force in x and y directions. So you can do this by setting the net force equal to the mass times the acceleration, since Newton's law tells us this, and then solve the resulting equations from there. So I'm going to apply this concept of Newton's second law of motion to a real example now. So I'm going to read it out loud. The question reads, 2 identical unlabeled boxes are transported to an orbiting space station. The astronauts know that one box is filled with a light sample of ants for an experiment, and the other is filled with heavy tools for repairs. How can astronauts tell without opening the boxes without which box has the tools? So essentially we have 2 boxes. Let's see. Okay, let's just leave it simple boxes. 2 boxes. One of them has little ants. So like here on Earth, you could easily tell that the ants are going to be really light, and then this one would be filled with heavy tools and big things that weigh a lot here on Earth. However, as said in the problem, that the astronauts are in outer space. And we know that acceleration due to gravity is 0 in outer space, so the weight of each box is going to be equal to 0. So it's not like you can just hold each one and tell which one is filled with ants and which one is filled with tools. So you have to use a different method. So we know that we can still measure the property of inertia or the mass. And so the box with the higher inertia or the higher mass will be harder to move back and forth when shaken. This relates to the Newton's second law of motion, because as you can see here, if the mass is greater, then the acceleration will be smaller, and if it's smaller, then the acceleration will be greater. So that leads us to the solution that if you move both boxes back and forth by shaking them, you know that the box with the tools, which have the higher inertia, is going to be harder to move back and forth than the box with the ants, which leads us to option B, which reads, shake each box. The box with the tools will be harder to move back and forth. So we know that option B is correct. Thank you.